I'm going to start off with just sort of like a philosophical overview of what we're trying to do, and then we'll just spend some time building calcs and sort of showing what the Excel interface can do from like a reporting context and just sort of thinking outside the box with different calcs. And then we'll also get into some of the AI stuff just to show how good LLMs are at writing Excel. Um, so at the highest level with Omni, we're trying to build a platform that is great for super technical users and great for non-technical users. And in between those two spectrums, there is Excel. And so for people that started in finance or for just people that spend a lot of time in spreadsheets, frankly, Excel provides this really interesting balance between the tangibility of being able to touch and feel things as you sort of build up calculations. But it's also essentially a programming language, and it lets you do pretty crazy stuff on top. And so we're going to sort of poke at the spectrum of different things that people can do with calcs in this sort of Excel style interface, starting from things like plus and minus and sort of row over row diffs, all the way towards, anything that you can imagine for visualization, but also like window functions and sort of much, much heavier things. So with that, I'm just going to dive into the app. I made a list of functions that I sort of want to just show the types of things that you can do. And I'll try to talk as to what we're trying to do and the sort of interesting things at the margin as we do it. But if people have sort of questions about what is possible, feel free to drop those things in as well. Let me try to find an Omni screen, and I think we have it. Okay, so the first thing to sort of understand about sort of building calculations in the UI is the trivial things that are typically very difficult to do in very rigid BI tools are very, very simple. So we're going to start with an e-commerce data set over Postgres. And to give you way too much information about how all this stuff works, essentially in the background, when someone writes a query, so when I do something like ask for users by quarter and order count, we're writing SQL. And that's fine. For very technical people, writing SQL is great because it lets you get the data that you need out of the database. Everything that we're going to talk about is essentially after that data comes out of the database. And so the types of things that we would want to do is sort of take this very basic chart, and I'm going to move these screens around a little bit, but take this very basic chart and be able to do slightly more complex or more interesting things with it. So we have orders over time. If we want to find changes of orders over time or sort of growth of orders over time, looking at the diffs between these things can be non-trivial. And so the first thing is that we built some of these calculations that we're able to do out of the box. So percent of total, percent of previous, running totals, things like this. If we just add a running total, we'll just get a running total next to something. The key is that all of this calculation is done through a pure Excel style syntax. And so what that means is that we're using the sort of classic A1, B1 grid. We have the equal sign in front of our functions, and that we have actually built our functions to be at parity with Excel and Sheets. And what's kind of super interesting for people that nerd out about spreadsheets is that Excel was not first to spreadsheeting, but essentially popularized the spreadsheet. And Sheets was built 20 years later and actually had a significant number of differences between the way they ran functions and the way that Excel ran functions. It turned out that users were happy enough with the way that Excel works, even though it does some strange things. And Sheets functions actually almost completely diverged with Excel. So they each have about 450 functions. I believe it's like 405 of them overlap. And so that means that we effectively have a standard for how functions work. Like when I type in a sum, whether it can handle an array or whether it puts out a sort of a string or an int, these things are all standardized now. And so that is how our functions work on top of the data set. So you can see that when we wrote this running total, it is written in this Excel syntax where on a given row, we can actually see how that function works. And we've got that $sign that locks it to a cell. And then the second part of the array is going to float. So the first one is going to be B locked to 1 over B1. And the seventh row is going to be also B locked to 1 all the way to B7. But even though we've got these little accelerators, we can actually write these things ourselves. So I'll just delete this for a second. And the first thing I'll do is just sort of remake that function and show you how that works. So we can go equals sum of B $1 to B1. And what's going to happen is we're going to fill this function all the way down the column. and it's going to do the same thing that the last thing that we looked at did. So that's very simple. The other sort of interesting aspect of this is we can start sort of offsetting these in different ways. So let's presume that we actually wanted to do this, moving running total in reverse. So we want to start it from the bottom of the table and have it work up the table. If this was sort of a special function, we would have to, write that ourselves. In Excel, there's actually a variety of different ways to do this. So the first that we could do this is we could just take the sum and we could subtract this number from all of these. So one example of that, we'll go sum b colon b, and we'll subtract it. And essentially now we have reversed our running total. And let me press enter so that goes away. But we have to sort of decide whether we want the 0 at the bottom or whether they want to show the value. And so there's like little preferences that can flow into this. But if we wanted to add the value back, now, I don't know what happened. I was in the wrong cell. So again, I'm riffing here, but let's add this cell back. And so now you can see that we're essentially adding the current row to that value. And so again, the nice thing here is that the results are going to be completely tangible. We're going to be able to touch and feel the things that we are doing as we build this thing out. There are actually other ways that we can write this function too. So this time I'm going to go the sum of b1 to b $15. And so here we're going to lock the back end of the array and we're going to let the front end float. And you'll notice that the function didn't change, and that's because it's actually doing the same math. And the nice thing here is the highlighting is locked, so it kind of shows us what we're doing. But again, like if you start thinking creatively about how the data set looks, you can actually come up with these structures really nicely. Let's remove this again. Another example of this, and let's zoom in a little bit so everyone can see, but another example of a type of place that you would want to use this is for something like a moving average. So if we want to just build a moving average, we can just do that by unlocking the full array. So here we're going to go from B1 to B5. The next cell is going to go from B2 to B6. And again, no rocket science here, but we've now built a moving average. We can actually start to see problems with this, which is, it's a moving average that's moving forward. So at the tail end of our data set, it looks less interesting. Maybe that's not the type of thing that we want. This is where we can actually start layering on these different functions. So I'm trying to think about how I want to do this because I want it to look different. And the first thing I'm going to do is I'm actually going to just delete this function and start over. And I guess it doesn't delete out properly, but we'll just go down here and fix it. Let's go back. Instead of this function going down, I actually want it to go backwards. So what I'm going to do is I'm going to actually change these references to go from, let's think about this, B11 to B15. So we're going to go B11 to B15. So now I have 5 moving backwards, but again, we've got this sort of stub at the front that I don't really want. And you can see that we're filling in a reference here because B-2 doesn't exist. But what I'm going to do here is I'm actually going to wrap this in an if statement. And if we want to sort of see this building block by building block, let's actually do these in different columns. So I'm going to call a different function called row. Go equals row. And you can see that this just gives us the row across all of these functions. So it's not doing anything too crazy. It's just giving us the row. And let's just say that we don't want this sort of moving average, alongside our data. So let's make 2 lines. Let's kill that row calc, which is this one. And maybe we don't want these early data points because they're deceptive for some reason. What we can do is we can actually come into this function and we'll say, if row is less than 5, then empty, else this. And this is where the power of kind of some of the things that we built becomes a little bit more obvious. Because again, to give you way too much information, databases really don't like this sort of mix of blanks or strings and values. And typically, if you tried to do this in SQL, you would end up with these tight mismatches that are very, very difficult to deal with. In Excel, the user doesn't have to care about those things. Like if it looks like a date, it'll behave like a date, or sometimes a number. If it looks like a string, it'll behave like a string. And we've actually built our functional library to work that way as well. So when I built this if statement, what's going to happen is we're just going to remove the front of this data set. And we don't need this column anymore. And so you can now see that we still have our function, and it still sort of works across this full data set, but now it's only taking the complete data points. And we can now visualize with it. And so these are the sort of interesting things that you can actually layer on in terms of, trying to build out more interesting things in the data table. So let's find some more examples. I guess a quick one that is worth highlighting here is, let's remove this for a second. All these things that we're doing with sums, we can obviously do with diffs as well. So we'll go, look at changes. So we're doing this one minus this one over this one minus one. And now we have our Q over Q growth here. This is a great example. We can just kind of instantly format it. And now we've got our growth. Again, we might want to stub out some of these things that are, exaggerated because of the way our data looks. And we can go in and clean those things out. Again, all the things that we did before. So right now it's one row over one row. If we wanted to go back a year, we can go do that very easily and sort of see and touch these data points. So a lot of functionalities around the sort of changes. Another interesting thing that we have done here, let's go look at transactions now, is the ability to actually work with dates. And for folks that are, again, comfortable in SQL, working with dates is extremely painful. So trying to work between timestamps and dates and date times can actually be very frustrating. One of the interesting things that Excel did is it treats dates like numbers. And that does a lot of weird stuff as well, but it does make things like math and actually building analytics very, very simple. And so an example of how that can get used in Omni is we will take an order and we'll take the created at time. So this is every order, and we'll throw ID on this table just so we can understand it. So we have every order and when it occurred, and this timestamp is really long, but it's got the time of day. And we can also look at when it got delivered. And so what we can see here is that our orders happen and then they are delivered in the future. And again, anyone can go build this sort of thing in a database as well. It turns out that all of our orders are tagged as getting delivered at 4 p.m. I don't know why, it doesn't really matter. But if we want to understand how long it takes an order to get delivered, all we need to do here is make our new column and just go delivered at minus created at. And what you can see here is we've actually just automatically calculated the number of days that it takes to deliver an order. This may or may not be in the form that we want to do something with, but it is very, very simple now to actually work with this data and sort of understand it. This gets into sort of the second interesting piece around understanding calcs, which is we can actually pick these things up and actually move them back into the data model. And then instead of using them as post-processing, we can actually group by them. So what I'm going to do is I'm going to actually take this. Yes.
So really quick on that, that's actually a great segue. So we just got a question from a customer. So thank you so much for joining. They said, we really like the feature that allows promoting table calculations to the model. However, we're wondering if it would be possible to promote calculations based on ranges in the future, understanding that there may be some limitations, such as calculations based on other calculations or those that include a range reference. But this is a question from one of our customers. So thank you so much for joining us today.
Let me finish this thought and then I'll answer that one, because the answer is maybe, but we need to figure some things out. So I'm actually going to do promotion here just to quickly show people. So this person asked about promoting these calcs into the model. So what we're going to do is we're actually going to take this time to deliver and I'm going to floor it, and we could round it or we could floor it. Again, these are just functions. We copied Excel on these. So this is a floor. I believe it will just turn it into an integer. Let's actually see. It does. So now we have the days to deliver. I'm going to add 1 to this also because floor is probably too generous. I think I could also use ceiling, and that will also do what I want. So let's do that. Now it's a ceiling, days to deliver. And so what I'm going to do is I'm going to promote this to the workbook. And so again, everything that we've done here is post-processing. So it's take the data and do this after the query. When I promote this field, what's going to happen is now this field is actually going to look like something that's coming from the database. And so if I clear this out, now we can look at this for every single ID if we grab ID as well. So this is going to look a lot like that previous table with those other columns removed with days to deliver. But if we remove ID, we can now group by days to deliver. And we can actually understand the number of orders and the distribution of how long they take to deliver. And so some of these aren't delivered yet. These are probably recent orders. But you can see that we've now taken this calculation that we just built really trivially, and we can model with it. Now, what's important to understand about promotion, to now address that question directly, is sometimes it's very easy and it makes a lot of sense to promote something. Again, going back to this example, if I grab that created at and that delivered at, each row here, it makes sense to pick up and promote this function because the row is sort of an isolated object. If we go back to that example that we had earlier with users and growth, so quarter and user count, and again, we'll come back here and we'll just do our percent change from previous. The challenge here is that this field is actually dependent on both this row of data and this row of data. And so the challenge is when we promote this field, now to actually use that field, we need the context of this data table. And this is where the sort of divergence between Excel and Omni becomes a little bit more acute, because in Excel, you just don't care about those things. Like if a new row is inserted, sometimes the calculation will move, but if you drag it down, it's just going to not care, and it's going to do row over row, not quarter over quarter. And so I think some of the things that we're trying to figure out is if we do try to pick up this function and hand it to you, and again, we're always turning this thing into SQL, we could hand you that function. It might mean different things in different contexts. So here it means quarter over quarter growth. But if, for example, I swap out quarter for week, our function now means week over week growth. And again, this is the same thing. It just doesn't mean the same thing. So we need to be able to essentially establish some context on fields. I think it is something that we would like to do. We're sort of just trying to figure out the right way to do it so that it makes sense for a user when they click on a thing over here. So we have some thinking to do. I can show you another example, though, where it actually tends to make a little bit more sense. So another type of common sort of calculation that people want to do is this idea of like a window function. So I'm going to grab two really small things. We're going to grab gender and traffic source. And these are just kind of the smallest categoricals. So we can see we've got two genders, female and male, and we have 5 traffic sources, Facebook, organic search, email, display. And I'm going to grab the count of users in each. And so you can see that female search and male search are the 2 highest. Sometimes we want to understand the percent inside a group. So if we add something like percent of total here, this is going to be percent of total across everything. 55,000 is 41% of, let's add our row totals, or our column totals rather. It's 55% of 134K. But maybe we want to understand what percentage of search traffic this is. So this is percent of total. Percent of total, we'll call it. We might want to do something like percentage inside category. So let's add a column here, and we'll say equals SUMIF, and I have to remember how to write a SUMIF function. So hopefully this thing will remind me. It's not. Okay, I believe that what we are doing is we are looking at the column that we want to check, and we're comparing that to a field. So we're saying SUMIF, this column matches this value on this row, and we're going to sum over C. So I'm going to write the SUMIF first just to make sure I'm right. And you can see that now for every sort of couplet of rows, we've done a SUMIF. Let's actually, sort this by this so we actually can confirm that is true. So yeah, every couplet of rows now has this. And so now if we want to do essentially our percentage inside a group, all we need to do is just take this row, and we'll go C1 divided by this. And this, let's press enter. This is the percentage inside source of source. We could also do the same thing for gender. So what I'm going to do here is I'm going to grab the same function and I'm going to insert a column to the right. And I'm going to theoretically paste this in. We can just change our B references to A references. And now it's the percentage inside each gender. And again, like it's simulated data. So it's going to look very similar for both of those. And so the nice thing is this type of function is very explicit about the windowing that it's doing. And this probably is a better candidate to go promote to the model. So these are just examples of sort of the more trivial things that can be done. All of these things can also be done against pivots. In the sort of interest of time, I'm going to skip to some of the more interesting ones, which is actually sort of trying to combine these things into different examples. So I'm going to open an example over here and I'm going to paste it in. But what we've done here is we actually have a time series and we have sales, and then we built this calculation on whether something is normal or not. And I'm going to go down a few rows so we can actually see it. But what we're doing is we're saying, if the row is less than 10, then we're just going to call it normal. So again, we've done some sort of exception handling. And then we've said, if it's more than 30% above the average of the last 10 rows, it's good. If it's less, then it's bad. And this is the type of like really simple function that just builds on some of those things. But we can actually apply this as a color to our visualization. So we can, take this function that we built and we can actually color by it. And it lets us, take these things and actually lift them into styling for visualizations. So I think these are really good examples of, how you might pick this thing up and use this in another context. Another example would be, let's just remove this for a second. And I'm going to insert a column right. I'm going to do this one by one. So let's just take a 5-period moving average. So equals average of this to this. And then I'm going to insert a column right. And I'm just going to go equals this minus this. So this is just whether it's above or below average. And all I'm going to do over here is just going to say if this is greater than 0. So this is just going to turn this into a true false of whether it's above or below the 10-period average. And this is an example now where we can see, our plot of things and whether they went up or down. And this is a little bit of a contrived example. But if we shrink this data set down a little bit, so let's filter this to the past, 20 days. This is a very common type of plot that you might do with a bar chart. And I don't know why it's grouping that way. It's because I have 2 calcs on here. It's grouping funny. So it's doing something a little bit silly here, probably because I have this calculation. But we can figure that out some other time, I guess. But this is just an example that sometimes you have bars and you want to color ones that are above or below the axis. And that's an example that you would do there. So let's go find another example. So I want to show off a couple of the kind of more interesting things that you can actually do with AI use cases. So let's grab this one right here. And you can see that this column is extract number after ID, but we're going to rebuild this from scratch. So you can see that we've got a column here and it's got ID and then it's got a sort of number attached to it. And it's really common that you'll get data sets that are sort of like, partially constructed like this, where we want to grab everything after the space. And in Excel, this is actually very straightforward, where we do something like a string find, which I think is find, and we're going to look for a space inside this. And you can see that it's the 4th cell always. And so what we're going to do is we're going to take the mid of this, mid of A1 from 4 plus 1, and we'll go for 100 characters. It's not really meaningful. But you can see that this is a simple way to parse out ID. And I know how to use these string functions. And so, I take some pride in being able to write these. But one nice feature here is we've hooked this up to an LLM. And so what we can do here is we could say, grab the part of the ID field after the space. And here we can actually have an LLM go write this function for us. And you can see that this is actually constructed very similarly. They wrote this find, they did the +1, they actually cut it to the length of the whole thing, but they just actually know how to write these functions and they're faster. So it can be very nice to actually ask for things, especially around sort of like parsing and adding fields. And again, we can now just make this a field by promoting this to the workbook. And rather than this sort of messy field, now we can have an ID. We could go write a join with it, do whatever we need to do with it. So I think that's a really fun example. What gets crazy is that you can actually go ask for things that you wouldn't typically ask for in Excel. So in this example, let me remove this column before I bring it over. We have a whole bunch of states in our data set, and we're just looking at US in the last 30 days, and we're gonna grab, total sales. Not really meaningful, but it probably actually distributes by state a little bit. And maybe we like that, and maybe we don't. Like maybe we actually want to adjust for population sizes in this because they skew a certain way. And so what we can actually do, because this LLM is hooked up to a little bit more than Excel, is we can do things. Let me grab the exact command. But here we've been playing around with some of these, so we learned them. And here we said, using a giant ifs statement, which is just a multi-if statement, return the median household income for every American state. And so what it's going to do, if it works correctly here, is it's actually going to write a giant if statement and go use whatever training data it has and actually bring data into this data set that we can then use. And it usually takes a second to do these. But if we go look, you can actually see, and again, I can't validate any of these, so this may or may not be a good idea to use, but I think what's interesting here is it actually avails to the user a little bit more than was sort of typically available in the BI layer, because these things are just naturally available through LLMs. So we could even try to riff here, but we'll grab, return the population for every US state, and we'll see if this works as well. But the idea is we could actually go now rebase our numbers by population, and we can sort of do it by sort of actively manipulating the result set and doing things like that. And so again, I don't know if these are right, but we now have population by state, and now we can insert a column, and we can do the types of things that we were doing before, like sales per person. But like maybe we'll do sales per 1,000 people times 1,000. And so like now we actually have a rebase number, and maybe this is more interesting and we can go plot it. So that's a really cool example as well. A couple more things that I wanted to show. So the next part where we're sort of trying to blur that line between a spreadsheet and a BI tool is we will go look at this users table, and we will grab traffic sources, and we'll grab count. Sometimes you just want to manipulate things by hand. Like we just want to bucket these for some reason. And we could go write an if statement. We could also go write a case statement. But one other piece of functionality that we've invited into the tool is I can create a hand category. And I'm just going to sort of randomly name one of these good and bad and good and bad and good. And there's sort of two interesting applications for this. So one is that we can plot with it. It just is available like anything else in the app. But the other thing is we can actually promote this field too. And when we promote this field, you can see that we just turn it into the same case statement that you would turn it to if you were modeling data. But I can actually now, group by source based on my hand classifier, and I can go build a pie chart of my hand classified sources here. So you can actually make these result sets like very tangible as well.
Hey,
yes.
Colin.
Mm-hmm.
So we have another question. This one is from our friend Martin at Corral. Hello, Martin. So specifically for Calc AI, Martin wants to know, can we know the source of the data that has been added to the LLM from Omni?
Yes. So we're just calling OpenAI right now, and we may introduce other things that can get tied here. In terms of the data that we are passing, the nice thing here is, let's just go do this with state again. The context window of the data that we're passing is actually none of the data from the data table at all. So let's go back and actually just reconstruct this. Where's country? Filter. So we'll grab country is equal to USA. So in this example, we actually aren't even passing it any of the data. All we are passing to the LLM is the headers and the functions that exist in Omni. So we're saying Omni has access to these functions in Excel. This is what the data table looks like with the headers specifically. I don't believe we pass any metadata even about the headers, but I could go check on that. And that's all that goes into the LLM. In terms of where the LLM is getting those population numbers or stuff like that, I have no idea, magic. But the context window is so small here because we're just taking these basic building blocks and sort of saying, this is a state, treat it like a state. So sometimes you do have to coach it over what the data set looks like to do things. But like in that string parsing example with the space, it doesn't know that there's a space in the data set. So it's pretty mind-blowing for how good it is at things that it probably shouldn't be able to do. So the last example I wanted to show is sort of this idea of VLOOKUP or XLOOKUP. And the sort of canonical example here is we'll grab, users by quarter. And again, just to sort of emphasize it for the SQL folks, well, that's joining through order items, but let's make this a query to the users table. So these are like signups into our app. It has nothing to do with whether they have booked revenue or anything like this. So this is new users. Just for clarity, I'm going to call this users. New users. We'll go make a new one on transactions. And we'll go by quarter and order count. And we'll call this new orders. And oftentimes you want to bring these two things together. And we can have another sort of LinkedIn Live about whether you want to model this in the database or not. But oftentimes the simplest thing to do is just really try to paste one result set onto the other. And so what we can do here is we can take advantage of XLOOKUP. And XLOOKUP is sort of the better version of VLOOKUP, for lack of a better way to explain it. And again, I'm going to have to actually remember what XLOOKUP actually looks like, because I'm more used to VLOOKUP. But let's just try to do it. So I think what we're going to do is we're going to look up this, and we're going to go look it up in users, in the users, and we're going to go look for it in column A. And then we would go like to pull the value in column B. And so what we're saying is go look for A1 in column A of new users and grab column B. And you can see what we're doing here is we've got 41 and we've got this, and let's go confirm those are correct. And they appear to be. All we're doing is essentially just a join between these two different tabs or a lookup. And the nice thing here is that when we now manipulate this tab, so for example, we go filter this by country. Well, let's not do that. Let's filter this for US users. So you can see now we're down to 38 and 4290. When we come over here, our lookup is going to adjust, and it's going to be doing a lookup of that tab. And so now we can actually bridge between these different things. And you can sort of envision a future where you can bring data to these things, but it makes it very easy for us to do things like pull time series and actually stick them next to each other. So now we have orders and we have users, and it really is sort of just that simple to bring data next to each other. So you can sort of see that with all of these things, you really get these building blocks to sort of do whatever you want. And again, like I think it's the composition of them that make them most interesting. So I'll show you an example that actually came up this morning with a different customer, which is we had traffic and we had user count and we had a chart, but we wanted to put this on top of the series with the number. So we have this ability to drop in labels. The labels use columns from the table. And maybe we want traffic source, maybe we want users, can we put them next to each other and actually stick them on the chart? So let's close this for a second. This is a great candidate for calcs. So we can call this chart label, just for clarity. And what I'm going to do here is I'm just going to concatenate these two columns together. And again, this is where the sort of tangibility of it becomes really helpful, which is, it looks like this, and that doesn't look very good. So let's sort of progressively fix this. So let's add a dash in there, and I forgot my ampersand. So now we have it separated. Now I want to format this. And again, these are things that databases are not very friendly about, which is I want this to be a formatted number, but it's in a string. Thankfully, Excel has already solved these problems. We can use this text function. And so here I'm going to format it with a comma. If I wanted to put a decimal on it, I could do that too. And you can see that I've now turned that into this. I'm going to have to remove this because it bothers me. But you can see that now we have the sort of label alongside the value, and I can jump over to my chart, and I don't want this on color, but I may want this on my label. And now I can build that on top of my chart, and I have this sort of flexibility to do whatever I want. So I could, I could go hide the labels at the bottom, I think. There's some way to do this. We'll do that another time. But the whole point is that you can actually really combine these things together really nicely. If we wanted this to show a percentage, for example, again, to drive this home, we'll make this equals this divided by sum of this. B colon B. This is a percentage. Instead of referencing B1, let's reference C1. Now, we don't want this to show up this way. We want this to be a percentage. So let's make sure we're getting two decimals. And now we've got our nice formatted percentages. And again, it's making it a gradient. And that kind of looks nice. So we'll keep that. But if we want the data label back with our nice chart label, we can go do that. And so this is where these sort of compositional pieces are very, very nice for bringing all these things together. There's a whole variety of stuff that we could do around pivots and sort of other types of functions, regression. But the whole idea is you're really sort of taking these building blocks and sort of weaving them together. I guess if we have a second, I can try the regression example real quick and just show you. So here, let's grab date and users. And let's make the row limit 50,000. Okay, we don't need it, but we've got this chart, and let's say we want to run a regression. So we have these slope and intercept functions. Right now, I want to turn this, let's go move this column over here. So let's go turn this into days since today, just so we have a nice numeric to regress against. I'm not going to label it for now. But now let's write our regression. So we'll go slope of, let's see if we're doing this properly, A colon A times B1. So again, we're taking a slope function, and just to drive it home, let's just go push that slope function through. I don't know why that's not showing anything, but there should be a slope function there. Did I reverse this? Oh, I did the wrong columns. So let's go C, B. Okay, we have our slope function, and we're going to multiply this by our value. So this is the slope portion. Now we'll grab our intercept. And again, wouldn't really recommend doing regression in SQL or Excel, frankly. But you can see that now we have, a regression. And let's go see what it looks like. We didn't guess very well, but that happens. So you can see, let's remove this calc, that we've now got our regression going through this. Maybe we want to plot our residuals or look at our residuals for the stats people. And so our residuals, we can just do this. Observed minus expected. Did I do that correctly? Yes. Residual. Oh, did I not type it in? Equals this, minus this. Oops. Minus this. Okay, we've got our residual. And again, our Gaussian's a little aggressive here. But you can see that now our residual is sort of plotted. Let's actually make this into that categorical that we talked about before. And so now we have our above or below the lines. And you can see that with these kind of very simple building blocks, you can actually, like really start building towards visualizations that you want by just composing these things together. And the really nice thing is like, we can actually use these to see whether our residuals are stationary. Now I'm turning into a stats nerd. They're not really stationary. So this is probably like a bad regression choice. But the whole idea is that you can actually take these really nice building blocks and actually compose them into something that can kind of make any chart that you can think of. So I think I'm going to leave it there. Tam, any more questions you wanted to hit before we sort of sign it off?
Hello, thank you so much. We've gotten a few comments in, just folks saying, that they love the integration of Excel functionality into a BI tool. So thank you so much to everyone who's joined us today.